Ordinary light consists of waves that vibrate in all planes perpendicular to its direction of travel. So here we have ordinary light, which consists of electromagnetic radiation that vibrates in all planes. Plane polarized light consists of waves vibrating in one plane only. When ordinary light passes through a polarizer, the waves vibrate in only one plane. In this case, it's the vertical plane, and we have what's known as plane polarized light. The optical activity of enantiomers can be detected and measured using a polarimeter. A polarimeter consists of a light source, a polarizer, a tube which contains the chiral compound in solution, and an analyzer. Plane polarized light is passed through a tube containing a solution of optical isomers. The plane of plane polarized light is rotated, which then passes through the analyzer. And finally, the analyzer is rotated until the light passes through, and the extent and direction of rotation can be determined. So here we have the plane polarized light which passes through the tube containing the optical isomers. The plane of the plane polarized light is rotated and measured using the analyzer. Next we look at how to distinguish between the two enantiomers of a chiral compound. The two enantiomers of a chiral compound rotate the plane of plane polarized light in equal amounts but in opposite directions. This property can be used to distinguish between the two enantiomers of a chiral compound. In this diagram we have enantiomer A and enantiomer B, which are both enantiomers of a chiral compound. Enantiomer A rotates the plane of plane polarized light 20 degrees clockwise. Enantiomer B rotates the plane of plane polarized light 20 degrees anti-clockwise. So as you can see, the two enantiomers rotate the plane of plane polarized light in equal amounts but in opposite directions. A solution containing equal amounts of both enantiomers is known as a racemic mixture or a racemate. If both enantiomers are present in equal amounts, the two rotations cancel each other out and the mixture is said to be optically inactive. So once again we have enantiomer A and enantiomer B, which rotate the plane of plane polarized light in equal amounts but in opposite directions. If we have equal amounts of both enantiomer in a mixture, the two rotations cancel out, which results in no overall rotation. Therefore, the mixture is optically inactive, which means it has no effect on plane polarized light. And finally, we look at the difference between synthetic and naturally made chiral compounds. When optically active substances are made in the laboratory, they often occur as a 50-50 mixture of the two enantiomers, which is optically inactive. This means there's no effect on plane polarized light. Biological processes within cells produce only one form of the enantiomer and are therefore optically active, which means they rotate the plane of plane polarized light.